right, here we go. So again, the title here is the binomial theorem. Title is binomial theorem. Before we actually get into using the binomial theorem, you have to know about this special symbol called the factorial symbol. And hopefully most of you have seen this factorial symbol before. In English class, it's called an exclamation point, right? In math class, it's called a factorial, okay? So what does a factorial mean? Well, basically a factorial is you just take like 10 factorial. You take 10 times, and then you multiply it by every smaller integer until you get down to 1. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, right? That would be 10 factorial, okay? 3 factorial would be 3 times 2 times 1, right? 5 factorial would be 5 times 4 times 3 times. You get the idea? Okay? So that's all that a factorial is, and that's what that symbol means. By definition, 0 factorial is just 1, which seems kind of weird. It should be like 0 times 0. Isn't that just 0? But no, we have to define it as 1, and there's this long, big proof that I won't go into about why it is defined as 1. So just for now, memorize that. And so for this first one, what is 3 factorial? Yeah, so 3 times 2 times 1, so it's just 6. All right, 6 factorial over 4 factorial. Well, if you think about it, this will simplify. You don't actually have to work them all out. 6 times 5 times 4 times 3 times 2 times 1. But look, this is 4 times 3 times 2 times 1. And I can cancel, and my answer is just
30.
Okay, so you can work through these and simplify and cancel things out. 20 factorial over 8 factorial. So another way, this would be like 20, 19, 18, 17. Once I get down to 12, I can just write 12 factorial. And why would I want to do that? Because down here I have this 12 factorial, right? And those will cancel. I don't actually have to keep going. Okay. And then there is still this 8 factorial. So that's 8, 7, 6, 5, 4, 3, 2. I don't have to write 1. And now I can start simplifying different things. So do you see anything that works out to cancel? Like 7 and 2 is 14. 3 and 5 is 15. No, but we could reduce here. Okay. So like 16 divided by 8 would reduce to 2. All right. 20 divided by 4 would give us a 5. And then you would, oh, where'd my 6? 18 and 6. So then you could just simplify the remaining ones. You just need a calculator. Okay, so speaking of calculators, your calculator does do a factorial symbol. So you could just do this one on your calculator too. Anybody know where the factorial symbol is?
Math and then probability.
Math, probability. So if I go to the math button right here, all right, press math. Under PRB, that's the probability functions. And there it is. Okay. But you have to put the number in first. So 20 factorial. And then you would divide that by 8 factorial. Oops, I didn't want to do that. Just kidding. And then multiply that one times 6, or 12 factorial, right? You guys got an answer yet? 125,970. And hopefully that's the same as how we were simplifying here. 5 times 19 times 3 times 17 times 2 times 13. Oh, yes, it's the same. Okay, so again, you could do this on your calculator, or you could try and do it by hand. You should just understand the concept of a factorial. All right, so your calculator, though, will not do problems like number 4, n plus 2 factorial over n. So how would I work out n plus 2 factorial? Well, that's n plus 2, and then what's 1 less than n plus 2? N plus 1. And then what's 1 less than n plus 1? N. And then I could keep going. But notice on the bottom here, I just had n factorial. So this is also an n factorial on the top, because it would be like n and then 1 less than that, and 1 less than that, and 1 less than that, right? So that's the same thing here. And so my factorials cancel. And my answer is just n squared plus 3n plus 2.
How do you know
It's not less, like, or more. Let's keep, like, how do you know you don't have to keep going? Like, n minus 1 would be.
So I could keep going, and then that would be n minus 1 and minus 2,
but then it would-
but then it would just cancel with all the ones down there, right? So if I kept going down here, then they would all just cancel. Okay, so you can cancel them ahead of time. All right, how about these guys? N minus 1 factorial, and then there's an n plus 1 factorial. So you want to start with the bigger one, the n plus 1. It'll then go down to n and then n minus 1 factorial, and that's the one that's going to cancel with the top.
1 over n squared.
So it would just be 1 over n squared plus n. Cool? So just being able to simplify these expressions. And the reason that knowing a factorial and using it is important is because it is in our formula for the binomial coefficient. Okay? And so let's move on to that. This is called the binomial coefficient. And what this does is it's a formula to figure out the coefficient of any row in Pascal's triangle. So like when we get to row like 27 or 24, these higher rows, instead of trying to start from 1 and generate all of Pascal's triangle all the way down there, that's going to take forever, this formula will figure out what is the actual coefficient for that spot in that row. Okay? So it's kind of a very important formula for us. And so what the binomial coefficient is defined as is n over k, and we actually call this symbol with these parentheses here is a combination symbol. So again, this is a little probability for you. So what this is called, it's a combination symbol. And the way we read it is we read n choose k. Because in a probability question, again, we'll do some more probability next week, if you had n things and you were choosing k of them, what are the probability, right, that I would have however many out of a group of 25 students and I picked 3 of them? What are the chances that those 3 would be girls? Whatever it is, right? So that's where this formula comes from. So again, the way you'll hear me say this is n choose k. And the way the formula works is right there. N factorial on top times k factorial on bottom divided by k factorial times n minus k factorial. So what we find out is that there's a direct correlation between these combinations and Pascal's triangle. Okay? So for Pascal's triangle, in the n plus 1 row are these numbers, right? N choose 0, n choose 1, n choose 2, n choose 3, n choose up until you get to n choose n. So what does that mean? Let me show it to you in Pascal's triangle language. Hi. Stephanie, yeah, where's she going to go?
See Mr. Gums in the back entrance.
Stephanie, Mr. Gums in the back entrance. There is a way to do this formula on your calculator as well, and I'll show you that. Let's just do a quick example here. If I wanted you to do like 5 choose 3, okay, and k always has to be less than or equal to n, okay, we would plug that in our formula. We'd have 5 factorial over 3 factorial times 5 minus 3 factorial. So that's 5 factorial over 3 factorial times 2 factorial. And then you can simplify this. 5, 4, 3. All right, cancel, cancel. Sorry, was that fast? Pause. Let that sink in. See what I just did? No. You're good. So 5 factorial, right? 5, 4, 3 factorial. Why did I stop at 3 factorial? Because I knew there was a 3 factorial on the bottom that would cancel. You found it? Yeah, there's a way on your calculator that'll do this for you in a sec. Okay. 4 divided by 2 leaves me with 2. So I got 10. But guys, you could just use your calculator. When it's numbers, okay, I'm going to show you how to do it on your calculator. If these are n's and k's and n plus 1s and stuff, you have to use the formula. So you do have to memorize this formula because you will have to actually use the formula for a lot of these problems. But on your calculator, let me show you where it is. Okay, so you go back to math, probability. Okay, and so on calc, it's math, probability, okay, and then it's going to be number 3, n choose r, NCR. Okay, but you have to put the numbers in first. I always forget to put the numbers in. So I'm going to go back. you put the first number in, which would be 5. That's the top number. And then you go back to your math probability number 3 and choose R, NCR, and then pick the 3. So I'm saying 5, choose 3. Okay, hit enter. Ta-da! You get the same thing.
Then why do we need to know that option 1?
Because sometimes I could actually these might be on a non-calculator part. I got to double check. Not for the quiz. The quiz is calculator on Tuesday, but then there is a chapter test at the end, and I want to say there are 2 parts, and one is non-calculator.
Are you serious?
Yeah. So something like this, I would expect you to be able to do without a calculator, just because it's knowing the formula and plugging in. These numbers are small enough that you could simplify it. When they get to be bigger numbers, you would need a calculator for those. Okay. So when it says the 4th row of Pascal's triangle, the 4th row, technically, if you look at your Pascal's triangle, that's the 3's, right? So like 4th row, 1, 2, 3, 1, 2, 3, 4. It's this row here, 1, 3, 3, 1. Okay. So using this, though, right, this would be, so 4th row is actually, I'm going to call it the 3's. It's really like to the 3rd power 1. So what we should get is 1, 3, 3, 1. Now we can just use Pascal's triangle to generate those. But let me show you how it would work with using this binomial coefficient pattern here. So using these, okay. Well, n is going to be 3. Choose 0. That should be the first one. 3, choose 1 should be the second one. 3, choose 2 should be the third one. And 3, choose 3 should be the last one. So when I do each of these, and again, you can just do them on your calculator here to save time. So if we do 3, choose 0, oh look, we get 1. Good. And when I do 3, choose 1, oh look, I get 3. And when I do 3, choose 2, I get 3. And when I do 3, choose, 3, guess what? Oh, I get 1. And so this binomial theorem just states that if you, whatever row you're looking for, so to the 3rd power, you just do 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. To the 10th power, you do 10, choose 0, 10, choose 1, 10, choose 2, 10, choose 3, okay? To the 25th power, 25, choose 0, 25, choose 1, okay? It'll work every single time. So this is very helpful for us when we got bigger ones, and we can't generate Pascal's triangle that whole way. We're just going to use binomial theorem for it, okay? So let's look at some problems and kind of typical types of problems I would give you. And there's one more formula you got to know. All right, so this is what we just talked about. Hold on, let me see my video here. Yeah, I'm going to